Okay, in this video, we're going to introduce the investigation. Okay, so what we're going to do is just have a quick look and put it in front of us here. So we're looking at different types of functions. I guess the heading says it all. The first one to look at is the surge. Okay, and that's actually what we're going to do in part A. So what we're going to do in this part, I'm just going to really go through majority of it with you and show you how to use technology and show you how to set it up. So the surge function, if you just have a look at the function just down here, there it is. Okay, it really is, it's just got an x multiplied by e to the minus x. Okay, and you just need to realize that it's got may have a different number at the front, which we call a, and it might have a different number up here, which we call b, and they're just positive constants. Okay, so even though you put a positive in here with the negative, it'll make it a negative value overall. This one will be positive here as well. All right, so what we're going to do, the very first part, we're going to tick this one off and go, right, let's start here. On the same set of axes, sketch the graph of y equals f of x and its derivative, where a is 10 and b is 4. Okay, and what I prefer to use is Desmos. So most students I have prefer to use that, but we're going to use Desmos to actually graph these. All right, this might be your first time using it, may not be, we'll see. But if you click on Desmos and just click on the calculator, you'll get this screen. Before you do anything else, I suggest you sign up, and you can just use your Google account that you've already got for the school. Okay, so I'm just going to log in, and you can see it says just sign up in with Google. So it'll only take you 10 seconds to do that. Okay, because every graph you do, you can save. Okay, you'll see at the top here, there's an untitled graph thing here, but as soon as you start writing functions, you can actually save the work. And I totally recommend you do that, because when we're giving you feedback, you might want to go back and redo your graphs. And so we strongly recommend that you actually do this for the investigation. So let's put this first function in. We've got f of x equals, now remember the a value was 10 times by x times e. Now just to do a up arrow, you just press shift 6. That's usually the same for everyone else's. And then you write minus 4x. Okay, so if you remember, they said let a, which is the number at the front, be 10, and the b value, which is up the top here, 4. Remember, it's got a negative out the front anyway, so it's always going to make it a negative. Now you can see your graph here. Now if you just left click anywhere on the screen, you can just move it around. Okay, you can press the plus and the minus to zoom in. But also you've got a much more accurate sort of setting with this spanner. So if you click on the spanner, we can change the window. So maybe we're happy with those x's. I'm not sure. I might make x pretty close to 0 and make it maybe go to 2.5. I don't think it needs to go any further than that. And our y-axis, well, I guess it's important to show that behavior below it, but I don't think I need to go any higher than 1. So I'm just going to put that to 1 right now. I've drawn the graph. Now it says to draw the derivative. Okay, now it's pretty similar to how you use your calculators. Underneath, let's call it a different function. We'll say g of x. I just put equals, and then here I just press D and then backslash to make it a fraction, then press dx, then the across arrow, and then I'll write the function in. Okay, so it's f of x. Now, the reason why we're doing this is we're looking for key features. Okay, so if you remember, it's quite easy to find the first key feature. There it is there. It's a max. Do you see that? So if I click on that key feature there, it gives that to me. But there's really only other, well, there's an x-intercept here. There's an asymptote, which looks at y equals 0. But the other main key feature is over here somewhere, an inflection. And remember, we need to graph the derivative. Okay, and if you remember the turning point, there it is. I'll just push it up a little bit. The turning point of the derivative is actually going to be the inflection on the original. So we know there's an inflection at x equals 0.5. All right, so we'll just go back to our instructions and just read them a bit more clearly. It says on the same set of axes, sketch the graph of y equals f of x and y equals f dash x in the case of a equal 10 and b equal 4. Now let's do the next part. It says determine the coordinates of the stationary point and the inflection point and label these on the graph. Okay, so let's go back to our Desmos and try and label them. Now you just noticed before, the max is here, the stationary point, there it is. But if you move the graph around, it disappears. So we need a better way to label. That's quite simple, guys. So, I mean, we could just click it, there it is. So we know the maximum's at 0.25. What we do is just click on another space down below and just put 0.25, comma, f of 0.25. All right, and you'll see a point appearing here, and then you can click label. All right, so if I click label, it appears there straight away. All right, you can actually add writing too if you wanted to write max. Okay, it's up to you, but the default will be just the coordinate point. Okay, now just watching here, if I put the cursor over here and hold left click, okay, see that? You can do this for any graph as well. I can change the color of the point. I can change the way it looks. I can move the point around. So I can move it to the right, to the left, up or down. So if you really like doing things with your presentation, you can do that sort of stuff there. You can even change the font size as well. Okay. I don't think I really need to worry about those things anymore at the moment. Now, like I said, we need the other key point, which is the inflection, which occurs roughly around here, and we can find it precisely by clicking here. So we know that the turning point of the derivative will be the x value there, will also be the x value where the inflection occurs on the original. So just like we did before, I'm going to have 0.5 because that's where the turning point is on the derivative, and then f of 0.5, and just put another label. And there it is there. Don't like purple? No, it doesn't matter. But like I said, you can change all that any way you like later by, remember, holding down left click on that. All right, maybe the derivative graph. So can you see here, I'm going to go over to that, hold down left click. I might make that a dashed line. I think that's looking a bit better. I might even make it a bit lighter, so maybe 2. Okay. And so what I've got is my first part of the investigation done there. All right, so we'll just go back to Microsoft Edge and just see what we've got there. Yep, I've determined, so for reading here, I've determined the coordinates of the stationary point and the inflection. All right, now you might want to talk about that in your investigation. So what I might do is just have all that info together and show you how to put it together a bit later. Let's see what we have to do next. It says repeat this investigation for 3 different values of A while maintaining B equal to 4. So just to keep a few windows open, I'll just go open up another Desmos. So I'll just write here Desmos, and I'll just put that original function in. So I've got, actually, no, I might use the other one, actually. Sorry, let's go back. Leave that. Yeah, so now that we've got that in there, it says to change it with 3 different other A values. So remember our first A value, there it is here. A was 10. Let's put in another one. So let's call a different function. We'll call it h of x equals, let's change it to 15 maybe. Okay, 15 x e to the minus 4x. So remember, if you go back to the instructions, it says 3 different values of A, but keep B as 4. Okay, so we'll go back here. So I'm keeping B as 4, but I've changed A to be 15. All right, now I need to do the same thing. I need to mark in those key points. Just note that it still goes through the origin. It still has an asymptote as x gets really large. It seems to be approaching a y value of 0. And have a look here. There we go. There's its max there straight away. So I can just do that straight away going 0.25, comma. Now it's a different function, remember, h of 0.25. Right. Let's label. There it is. Now I need the inflection. It kind of looks like the same point, doesn't it? So I might just use this graph that I've got already. So this function was the derivative of f of x. Look what I can do here. I can just quickly change that to be h of x. All right. Now remember we're looking for the x coordinate, and by coincidence, it's actually at x equals 0.5 as well. Okay. So I'm just going to do another labeled point of 0.5, comma h of 0.5. Just label that on our graph, and you can see it just pop up there as well. So really, the derivative graph is, we might talk about it at the end, but the derivative graph isn't really needed near the end because they say, look, let's draw 3 graphs and have a look at it. All right, so I'll just go back to those instructions. It says, graph 3 different values of A while maintaining B equal to 4, and then report and summarize these findings in a suitable table. Now, I haven't got the table with me at the moment, but I do have a copy of it already saved. So if we just go over here, there we go. And you can see how I've labeled this. I've saved it as part A, changing A. So I recommend you do this when you do your graphs, okay? And you can see I've got these graphs all labeled here. So the original one, which is f of x, there it is there. It's got an A value of 10. The next graph, which is in green, is h of x. There it is. And the A value is 15, okay? And then the next one, which is in purple, is t of x, which A value of 20, and so forth. So really, when you're looking at these graphs, we're looking at those 2 key points. We can also talk, hey, they all go through the origin. They all have a horizontal asymptote of y equals 0. But what we really can say is, hey, look, they all have a maximum at the same x value. They all have a inflection point at the same x value too, which is at a half, okay? You might want to deduce, hey, look, that's 0.25. That's actually double. So maybe there's some sort of relationship there. But the one key thing is, I hope you can see, as the A value gets bigger, you see those A values are getting bigger. The height of the graphs is getting bigger. You might even want to use words like dilation in that case as well. All right. But that's what we need to do. So you could put that information in a table as well. Okay. And then you just talk about what you've seen from those graphs. So we'll just check on here. It says report and summarize these findings in a suitable table. So in your investigation, I'll show that to you right at the end. I'd suggest you have maybe a table to start with, and then the graphs. And then what you do is you then basically talk about those. And now underneath, it says state the effect of changing the value of A. All right. And so that's really covering what I've just said there as well. Okay. Now, using a similar process, investigate the effect of changing B on the graph. Okay. So rather than just redoing everything again, I hope you understand it's exactly the same. You start with an original function. All right. So I'm going to do one that I've already prepared here. All right. So I've already got one saved. So I'm just going to click on my graphs. There we go. I've got part A changing B. All right. I'm going to open this graph. So if you look at my graphs here, I started with the same one I started with before, where A is 10 and B is 4. But if you look at these graphs, you can see that I've kept A the same. That's what it's saying in the second part. But I've changed B. So B was 4 initially, then it became 6, then it became 8, then it became 10. All right. I was also graphing derivatives to identify where the inflection was. And you notice these are different, right? So I should be putting this graph into my investigation. I should be saying, hey, look, so this is the B value here was 4. B value here is 6. So it looks like as I'm increasing the B value, the maximum is getting lower. Do you see that? The inflection is sort of becoming lower as well. And try and use really mathematical words that you might want to talk about dilations, and try and look for some relationship between the two. I mean, as the A value changes, I can't really see too much, but I think there's something special happening with B. All right. This is a quarter. That's 4. This one looks like 1/6, and that's 6. All right. So it's up to you to try and sort of find out what really the relationship between the two is. Okay. They're the 2 graphs done. So you said using the similar process, change B. Yep. And then you make a conjecture. Now, you might not be too confident on what you can conjecturize about. You might just want to say some things like, I just think that as you increase B, so if we go back to the graph, right, as we increase B, the maximum becomes smaller, okay? I might want to confirm, though, oh, look, they still look double. My other conjecture could be that whatever the x point of the maximum is, the inflection is double it, right? That seems to work, doesn't it? 0.1666 doubled looks like it's 0.33, and 0.125 doubled, yeah. So you just try and come up with some conjecture, All right, and then the last part of that is to prove it. Okay, so you'll see down the bottom there, it says prove the conjecture. And what we'll be doing in class is actually working on those conjectures together. Okay, so we'll be giving you some help for that. There might even be a video on that as well. All right, so like I said, we've got to put all that together. I think I might just keep running with this sheet, and I'll show you how to put that together in a couple of minutes, okay? So it says in this last one, it says, comment on how suitable a surge function is for modeling medicine doses, okay? By relating the features of the graph, all right? So the most important thing I need you to do for this is get some data, whether it's dots, okay, or whether it's some sort of graph, find it, okay? So I'll just, so the first thing is find some data, okay, and then look at your graphs, look at the data, and just talk about how suitable they are, okay? And discuss any problems with it, really. That's what I like to think limitations are. You know, what does it work for, what it doesn't work for, and it's looking for about 4 key points there. So what I've got on this one here is I've just Googled modeling medicine, I spelled it wrong, doses using surge models, and you'll see a few popping up. I know the second one here, if you click on that one, it's probably the most common one, but if you scroll down, there you go. So the second one I got here, so try not to use this one, but certainly just Google using that and try and find some real data. This is actually Viagra, which is kind of a funny one to find, but it is one of the most common ones out there. It's usually the first or second hit when you do these searches. All right. So I'm looking at that graph, but also I'm looking at this graph as well, right? So it doesn't matter which one I'm looking at. They all go through the origin. They all have a steep rise to a maximum, and then they still have the same concavity, but then they inflect, and then they tend to decrease in that rate until they approach that asymptote. So I guess when you're talking about your example, you need to be relating to that graph. So if I go back to the graph now, you know, I'd be saying things like going, hey, look, it does look similar. We rise to a maximum, and then it does, hey, look, there does look like there's an inflection somewhere around here. So it does seem to fit reasonably well, doesn't it? But then we can start talking about things going, well, if it's a drug, it's probably going to leave the body. Whereas our graphs have an asymptote, don't they? So it's a bit of a technical one, but it may be a bit limited, our model, in that. You know, if you want to be really specific here, I think there's another change in concavity with this graph. Can you see it's sort of happy to start with? Yeah, do you see that? So if you were focusing on this data set, you could actually argue that there is another inflection here, which wouldn't be represented on the original. All right. So, you know, I guess we could look at the numbers here. Can't even read them here, but, you know, we're talking about the absorption of a drug over time. It does seem to be reasonably suitable, but you need to have about 4 key points to discuss. So it says here at least 4 key points to be made. So talk about how the data or the graph that you've picked from real life is related to it. And then also talk about how there are some limitations. So I've given you a couple there just to get started. All right, so let's talk about how we put this all together, I guess. So I've got a Word document open, ready to go. Certainly there's a lot of work to do in this. So I guess when you have your investigation, you would have an intro to start with, right? Intro, not too sure what that looks like at the moment. You just need to realize that I think you need to finish the investigation before you can actually talk about what's in it, can't you? Okay. But when you talk about writing this up, I guess when you talk about part A, you probably want to have an explanation of how you are finding the key features, okay? And that's probably where this graph would come in very handy, okay? So you might want to have this graph. Why don't we get the second graph off there? So remember, the really first thing to do for this investigation was to I'll just get rid of the other key points too for h of x. I don't know why it's done that. Doesn't matter. Oh, it's because I still click the labels, that's why. So when you're looking at the original graph, let's make sure we can zoom in and show it. You probably want to explain how you found your key features. So I'm just going to have those two key features there. There's the other one labeled as well. Okay. And then you might want to just quickly explain that underneath. So I'm just looking for my label there. There we go. That's much better. So you probably want to do print screens. So I'm just going to do a quick print screen. So you don't have to do it this way, but certainly you probably want to have some sort of idea of how to do it. This hasn't gone as well as I thought. That's okay. Let's bring that down. So you talk about how you're going to investigate the search function. Then you're going to have your diagram here. You're going to call it, I guess, figure 1. And you're going to explain that, this turning point here is going to give us the inflection point there, because the investigations ask you to do it, right? So I would strongly suggest that you do those things as you go along, okay? So once you've done that first part, so you go, look, I'm looking at a search function, and this is how I'm going to do it. The next part is to look at changing the value of A, all right? So you might want to have another heading. Again, completely up to you how you do this. So you might want to changing the value of A, all right? And you could do another print screen there, but just to save the pain, I'm not sure how it'll work out. You'll have a graph, okay? We know how to find all those values using the inflection, so we don't need to do that again. And we discovered that, right, didn't we? Okay, even though my graphs are a little poor here, you'll find that all of them have the same X value for the max, and they have their all same there. So it might not look that clear on your graph. So you should, and just like the investigation says, you should have a table as well. So you might want to have graph, and then you might want to have the value of A. So in each one of these, the value of A was changing, wasn't it? It was 15, whatever. You might want to have the value of B. And in this case here, the value of B always kept the same. And then you might write down the key features, the max and the inflection. I don't know if you want to talk about others like the, X, Y intercept, question mark, asymptote, question mark. Okay. So having all that information in front of you, then you discuss. Okay. So, what do you notice? Okay. So I think you guys can sort of remember, we do notice that the X coordinate for the max is always in the same point. The inflection X value is in the same point. Just the Y values are getting larger. Okay, you write down everything you can, maybe talk about the asymptotes, that they all go through the origin. All right. And then you start talking about changing B. So what effect does changing B do? All right. And guess what? Yeah, get your graph from Desmos, put it in. And yeah, if you can remember, we sort of start up here and they sort of get smaller, don't they? Okay. And you'll have all your key points mapped out. All right. Make sure your axes are labeled, f of x or y. You might even want to have the functions labeled. This is y equals g of x, etc. So think anyway about the way you present it. Also have your table underneath. Okay, so you'll probably have something similar. Obviously, you don't need to copy mine. I'm just giving you some ideas. So you've got your function, you've got your A, you've got your B, you've got your key features of max and inflection and whatever else you want in there. Okay, and then you discuss what you just have seen. All right. So you just go, whatever you can get from there. Okay. They seem to be dilating. The maximum X value is becoming less, right, as B gets larger. Whatever you can get, and having the table and the graph both in front of you will help you do that. All right. Now, once you've done that, then the sheet says come up some conjecture. Okay. Now, do you remember we said it earlier, like your conjecture could be very simple. You might say that the inflection X value is 2 times the maximum x value. Okay, write it clearly though. I'm just writing it really note form here. You might come up with other conjectures. As a increases, y value of max increases. All right. So you need to come up with some sort of conjectures, okay? And then after that, you prove, okay? Prove. And like I said, that's probably going to be in class. So we'll help you guys with that. And like I said, there's probably going to be a video on that anyway. If you just use ChatGTP, it'll come up with you, come up from that anyway. All right. So once you've done the proof, remember the last part is talking about real life modeling. Okay. So, we had our model. So real life models. So what have we done? We've talked about the surge function. We've looked at changing A and B in it. We've come up with some ideas on what's happening and we try to prove it. And then the last thing is the real life model. So what you do is you get some data, you reference it. We had our graph. You talk about where this is from, reference it, an explanation of how it's important, and then discuss how it's similar. Okay. And discuss some limitations. Okay. So do you remember, what was similar? It still had a max. It still had an inflection. All right. And try and get into a lot of detail. Look at your graphs and look at where these key features are on these graphs. And the limitations, like I said, ours looked like it had another inflection. Okay, just for that specific model. But other things is, we have an asymptote, right? At y equals 0, how does that, that doesn't really fit in with real life data, does it? Because the drug should leave the body. So, when you've got an asymptote, we can't actually effectively be 0. And you need to come up with others as well yourself. All right. So, yeah, I don't know if that's really messy, but, it gives you an idea. Okay. It is an information overload, but it is all covered there. Okay. So I think one of the most important things is when you're using Desmos, saving your graphs. Okay. So you can see here that I've logged in. And so you can see I've got changing A and changing B, mainly because you might want to go back to these graphs and just change them or maybe revisit them later. We might even give you some suggestions on how to present them a bit better when we're giving you some feedback. All right. Answer the questions on the sheet. Okay. So I've ticked all those off. All right. And certainly I think I've shown you quite clearly how to do all that. And you just need, and I've also given you an attempt at how to write it up as well. All right. And really, that's really all the part A done there. All right. So just leave the intro for now and just sort of explain all these steps as you go along. Okay. All right. It does all have to be typed up. So you need to be working with either Word or a Google Doc. Certainly, I'd recommend Word if you can, if possible. All right. That's it for part A.